Sounds good. Well, hello, everyone. Thank you again for joining this week's Lunch and Learn or event in the AI Lunchbox Series. Tom Cain here with the Center for Applied AI at UMBC Training Centers. Again, glad that you're spending some of your lunch hour with us. We're very appreciative of that. Today will be maybe a more informal presentation than a couple in the past and many in the future, but hopefully it'll also be an informative one. And Tushar, I'm sure you'd agree.
Yeah, I think this will be probably the most fun conversations we have had in a while. We're gonna keep it free flowing. We'll chat about some of the things that we are excited about, and we'll let you chime in and love to respond to you. So yeah, so take it away, Tom.
Yeah, and as usual, we'll try to wrap this up around 12:30. Tushar and I like to talk, so we'll do our best.
Okay. Yeah.
So today we're going to be talking about some of the major developments or announcements in AI over the last few weeks, and perhaps a few other nuggets that we think are really important to AI. But before we get started, there are a few takeaways that I'd like to mention before we even get started. First of all, what we talk about today, I think, shows the incredible speed and in some cases, unexpected speed at which AI technologies are advancing. Second, we will highlight one unfortunate sort of unintended consequences of some of these new technologies, which show that there's still work to be done, lots of work to be done. At the end of the day, many of these technologies are simply software, and software tends to break occasionally. And hopefully we'll get to it, even international impact on certain AI developments. In particular, Microsoft invested in a French company, and many of the EU countries were a little bit they were surprised at the investment, and it generated a lot of discussion even in the EU. So Tushar, did you want to add to that? Are you good?
No, I think you covered it. I think we have some really cool things that we want to talk about. And I think that in addition to just the news piece, I think we'll provide our own perspective on what these things are, what they mean, and how it's advancing the world of AI forward. So as we talk through this, be thinking about and asking questions around what does it mean to you, and whatever else comes to mind. So yeah.
Yeah, it sounds good. So we're going to definitely talk about three things that were pretty major in the last 3 weeks. First of all, Google released Gemini and what you should be looking at now. And we're good on that. Everybody's seeing welcome to the Gemini era.
Yeah.
All right. Good. So we'll talk about Gemini and another Gemini technology called Gemini 1.5 Pro. We're going to talk about why that was important. And then we're going to get into Sora. If you haven't heard of Sora, well, great. I'm glad that we were able to bring you across some of the really important developments in AI over the last 3 weeks. So let's first talk about Gemini. Well, Gemini really is a series of, or a stack of large language models. They come in 3 flavors, Ultra, Pro, and Nano. We're going to be talking about a bit about Ultra and about Pro. That page, actually, it's a Google page, but this is actually old. There is 1.0 Ultra was released 3 weeks ago, and this is even old. 1.5 Pro was released a couple weeks ago. So hopefully we'll make sure that you understand the differences here. But in any event, Gemini is a stack of large language models, and Nano is what will be used on mobile devices. So to start out with Gemini Ultra 1.0, this was announced, look at that, February 8th, just 3 weeks ago from today. And it is really called Gemini Advanced, as as an AI assistant, if you will. But underneath the covers, it's running the Gemini Ultra 1.0 large language model. So let me, I'll make sure, just trying to drive you through this in a sensible fashion. So let me go to here. So Gemini Ultra 1.0, again, released 3 weeks ago. This is what it looks like. Okay, this is Gemini Advanced. Notice this, there are two separate AI assistants from Google. One is Gemini, which is free. Gemini Advanced costs $20 a month. And in about 3 weeks, I think it's 3 weeks, I'll be running through some details of Gemini Advanced, showing as many of the features as I can. One thing to notice is look at the updates already. So it was announced, look at the date, 3 weeks ago. Bard is now Gemini. And since then, they've added a couple of features, one of which is exclusive to Gemini Advanced is edit and run Python code for you developers out there. So again, we'll discuss that more in about 3 weeks. So again, this is Gemini Advanced running on Ultra 1.0. And I'll just mention that a couple of nice things is, let me see where I am. Okay, here. I won't talk much about this. Just wanted to show you the interface because it was released 3 weeks ago. But one of the things that is kind of nice about Gemini Ultra is it really does integrate with the Google apps that you see here, like Google Workspace, Gmail, Docs, Drive, etc. Again, in 3 weeks, we'll have a lunch and learn to show how that is, how that integration is happening. One of the things I'll mention right away is what's missing is you can't upload PDFs for summaries like you can with ChatGPT and other AI assistants. You can't upload a spreadsheet for analysis yet like you can with many of the other AI assistants. And in fact, next week or the next 2 weeks in the AI Lunchbox series, we're actually going to talk about data analysis and data visualization. So we'll talk about some of the tools that really help you there. So those should be pretty interesting. Well, the last thing I'll say about Gemini Advanced is, and if you can bear with me while I find my cursor. Here we are. Oops. So I'm going to, okay. So when Gemini Advanced was released, you could do image generation like you can with ChatGPT or DALL-E 3 in particular. But there was an issue last week and it caused them to pull image generation off of Gemini Advanced or the Gemini models. And it says here, 3 weeks ago, we launched a new image generation feature for Gemini. And they included ability to create images of people. However, some things went bad. The feature missed the mark. Some of the images they say are generated are inaccurate and in many cases were offensive. It really made a lot of noise on the internet, on X and other social apps. But I think this is a case where you say there's still work to be done. So this hurt Google in the I think to the tune of 9 billion in market cap. Just over the last week, their stock dropped because of this. So it wasn't a good week for Google.
Are you putting a stock tip over here? Are you saying that it's a good time to buy Google?
I would say it's probably a decent time to buy Google if you believe that they will indeed if
Get it right.
Yeah, if they will indeed
Yeah. Very cool.
Right.
Yeah,
if they'll get better.
Yeah.
So this was their apology from just a week ago, right here. So we'll release all these URLs in the Slack channel, sort of as usual. All right. But now what I'll move on to is something that is quite incredible, which is the next generation model. So just a week later, on February 15th, as you see here, they announced Gemini 1.5. And Gemini 1.5, I want to make sure that I have what, okay, good. I want to make sure that I'm on the right tab. Didn't want to click around in the interest of time. But when this was announced, people were shocked. And this was a case where just 2 weeks ago, Google was on a really good track. A lot of people thought Google was behind in this sort of AI assistant or AI large language model race. But then when they introduced this, people went pretty crazy. And why did they go pretty crazy? It was because reasoning about vast amounts of information. The technical term is that it was the first model that was released that could handle 1 million tokens. Well, what is this token thing? So a token is basically it's a basic unit of meaning for natural language processing. It can be a word, a part of a word, but it's part of so-called context length. And the context length refers to the maximum number of tokens an LLM can consider at any one time. So in other words, you can put very large documents into this AI assistant, and it can, at one time, can handle, say, books of 700,000 words. It can handle videos of 1 hour long, where it can make predictions about the video that you uploaded. So the concept of a large context length, or often called context window, means that at one time the model can go ahead and understand context of all the data, in that 1 million token window. So what I'm going to do is just take a moment here and show you a quick video, and let me know. Hopefully it sounds good. Tushar, if you can let me know.
I will. Sounds good.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 402-page PDF of the Apollo 11 transcript, which comes out to almost 330,000 tokens. We started by uploading the Apollo PDF into Google AI Studio and asked, find 3 comedic moments, list quotes from this transcript, and emoji. This screen capture is sped up. This timer shows exactly how long it took to process each prompt and keeps
I think we lost the audio.
of coffee on it. If we go back to the transcript, we can see the model found this exact quote and extracted the comedic moment accurately. Then we tested a multimodal prompt. We gave it this drawing of a scene we were thinking of and asked, what moment is this? The model correctly identified it as Neil's first steps on the moon. Notice how we didn't explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details. And for the last prompt, we asked the model to cite the timecode of this moment in the transcript. Like all generative models, responses like this won't always be perfect. They can sometimes be a digit or two off. But let's look at the model's response here. And when we find this moment in the transcript, we can see that this timecode is correct.
Okay, so that's pretty incredible. So that was an example of a 402-page transcript that the model was able to handle. And the next one, I'll go ahead and do a short clip here, which has to do with video upload. And I apologize.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode. This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman and Company pawnbrokers with the date and cost, and it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact moment the piece of paper is removed from the person's pocket, and it extracted text accurately.
Okay, I'll stop the video there. I think that is enough to convince people of how incredible a 1 million context window, 1 million token context window is, and what it may do for for analyzing large data sets in the future. With that said, as if that wasn't enough, that we've got Gemini Advanced released 3 weeks ago, Gemini 1.5 released 2 weeks ago. Tushar, I think it's time for me to turn it over to you, and I will make sure that I stop the share. All right, so we're going to move on to something called Sora. So I may have to stop my share. Do I?
Can you see my screen? Okay. Now we can.
Yep.
So I want to start off with this brief video clip. This is Sora. This is on OpenAI's Sora site. This is a video generated completely by the Sora engine. So you put in a text prompt and the engine generates this video. This is just one of many that they have put out. Here's another one. Incredible. Look at that level of detail. This is all AI generated, right? So I don't know if you've seen some or any of these. I mean, look at that Disney video coming up or Disney movie coming up. Something like that, right? It's just incredible what they have done with this, right? So what this takes us, or where this is going. So Sora is based on, as we were just talking about, Tom was describing the overall piece. I wanna go back and talk about tokens and patches, but before I go there, I want to start off with some basic stuff so we can all align, right? So when we think about a generative model is all about, learning from and making predictions based on that data, right? So the way it learns is it consumes a lot of that data, and you learn the ML engines, machine learning engines on it. And then based on that, it makes predictions based on probabilities. So it is a probabilistic engine and not a deterministic engine, right? So it is never for sure. It is based on whatever the highest probability is, right? Now, that means that the quality and quantity of data on which your model is trained is really important, right? So that's why the large language models and how much it can, learn and capture, and how much it can put out, and the number of tokens and all that it can consume and use, all of that becomes really important. And of course, this is a very complex sort of thing, and there are so many different layers. But without getting into the technicalities of it, right? So the generative model is basically understanding that, taking in the data and understanding what comes next. And that's why the GPT, generative pre-trained, meaning that model has already been trained on that data, so GPT. Now, the types of generative models, there are basically two basic types. One is the transformer, that is what we were talking about, that predicts what is the next. In this case, GPT models, in this case, mostly text models, it will say, okay, what is the next word that should come in? And based on that probability, it will generate that response. Now, there is another type of model called a diffusion model. The diffusion model is about destroying what is existing, right? And as you destroy it, you learn, the engine learns how it was destroyed, and it learns to recreate that. So it's kind of similar to the reverse engineering concept, right? So what is happening now is that the two models are now being combined in diffusion transformer models. So what you do is you destroy, you predict, and then you create. And that kind of that kind of model is being used. So a lot of what Sora is using is, is the diffusion model, and building up on that using the diffusion transformer model. So what can Sora do? Sora can do multiple interesting things. So one is, give it a prompt, and it will generate a video for you, right? And it says currently it can generate up to 1-minute videos. The access is highly restricted or limited to the red team, but I think they're rolling it out soon. Right? There are some very interesting other things that it can do. Like, for example, it can extend an existing video. So if you have an existing video, you can prompt Sora to consume that and extend it for another 10 seconds or 15 seconds. Or you can have 2 or 3 videos and Sora can help transition from one into another. So it can build that bridging video of 10, 15, 20 seconds up to a minute right now. So all of this, like it can create, and what it does is, in addition to the level of technical complexity that they have solved for, it builds some very interesting use cases. Like, for example, you can imagine a future in which people will build their own movies, or the movies can be customized to the ending that I like, that I want, right? I mean, it's a whole different world that is possible. And now combine that with Apple's Vision Pro or something like that. And you can imagine, self-entertainment to a whole different level, right? So, I mean, it's mind-blowing what this opens up.
And Tushar, if you don't mind me interjecting here. So Sora, and I don't know if you mentioned it. If you did, my apologies. But Sora is an OpenAI project.
Right.
And Sora was announced the day after Google's Gemini 1.5 was announced. So just when Google thought they were on the top of the world with a 1 million token context window,
Right.
the next day, OpenAI shocks the world with this text to video, video to video, and I think image to video technology. And it's not available publicly right now. I think it's referred to as red team usage. They just want to make sure that a select few people get a chance to check it out and make sure maybe bad things won't happen.
Yeah.
Wasn't there a famous, I don't know, actor, somebody in Hollywood that was impacted by this, Tushar?
Oh, the Tyler Perry incidents. Oh, yeah.
Yeah.
That $800 million studio project that got canceled because they saw this video and they said, oh my God, there is no point in me creating a physical video, a physical space, if all of this can be done, in a matter of seconds using this technology, right? Which really makes sense, right? I mean, and now all of us have the power of, or will have the power of, creating something like this. And all we have to do is learn how to prompt it. And that takes me to another. Did you hear about that new news release from Jensen Huang, NVIDIA's CEO?
No.
That was an interesting comment he made. That there is a video on that, but he basically said that the coding career isn't what it used to be. You don't really have to learn coding languages to code, because the computers of the future will code using human language, which is the prompting, or which is prompt engineering field, right? So pretty incredible. I mean, all of us could be programmers, all of us could create content, all of us could, and that's the exciting journey that is happening right now. It just gives me goosebumps thinking about it.
Now, and given the so these technologies take a lot of compute power. And with that said, I think we should move on to Grok. What do you say, Tushar?
Let's do that. So Grok, G-R-O-Q, Grok is an interesting model. It was created by ex-Google engineers. So these engineers were working for Google's AI team called TPU, Tensor Processing Unit, if you're curious. So what they did was they took a completely different approach from how the current chips are designed, right? So currently there is a lot of general purpose AI chips that are coming out, and that's what we are seeing in the chip market right now, which with Nvidia and a lot of other players now jumping in. But what these guys did was they started with a software. So software first approach or software first architecture. So they created the entire software stack with the compilers and everything, and then based on the compiler outputs, they designed chips that would consume those things and provide output in the fastest way possible. And for now, this is an inference engine that they've designed. So it is a very special purpose chip. And it's called the LPU, or language processing unit, right? So it is defined for just that particular purpose. But the way it has been architected is that it is super fast. It is so much faster than anything else that is out there. The downside is that it is only for a purpose or a set of purposes, and which sort of brings the possibility of the future hardware or future laptop. Your next laptop may have a combination of these highly specialized chips, where this chip does this chip does this, and then architecture, motherboard architecture that optimizes the use cases around that. But we have something more exciting to take a look at. Tom, should I hand it over to you, and you can show us some of the exciting work that you've been doing with Grok and playing around with that, and how we could use it. You may be on mute. Yeah, I think that would be exciting. So yeah, so while Tom is coming off of mute, what we're going to do is he's going to log into Grok, and it's going to show us what it can do, and maybe even wow us with the speed of Grok.
How's this? Am I now off mute?
Yes, you are. Thank you.
No, thank you and everyone else. So do you see my screen there?
Yeah, I do.
So this is grok.com, and don't confuse Grok with a Q with Grok with a K. Grok with a K is Elon Musk's their work on large language models, etc. So this Grok is what is the company that Tushar was just talking about, with the developing language processing units, which are going to be pretty incredible. But if you go to grok.com, they just released this. So this again is like, I think, only a week old, where Grok put a UI to make an AI assistant. It's always hard to say AI assistant. But I want to show you this. You can choose two language models. One is a company called Mistral, and I'm just going to handle my screen here for just 1 minute. Mistral is a company out of France. And this is what I mentioned at the very beginning of our discussion, that Mistral, Microsoft just invested in Mistral, and they've come out with pretty significant, fast, large language models that are open source. So they are really focused on open source. Many of you on this call know Apache, the Apache project. So they are working with Apache on that. So there's the Mistral model. And then Llama 2 is Meta's model, also open source. So you can play around with two open source models. There's no cost to this. But one of the things that is pretty incredible, again, is the speed here. So I'll just say, what is a context window what is a context window for an LLM? And that is fast. So this interface is incredibly fast. Again, this is using Mistral. So one of the things you'll notice if you play around with this thing is, let's say, give me information on tokens in an LLM. 6 bullets, please. it's just super fast. So definitely wanted to introduce everyone to Grok with a Q, and again, free to use, and they are doing their work with 2 open source models. Anything else that we may want to talk about, Tushar? Otherwise, I think we can move to some questions.
Yeah, let's move to some questions.
Because we're at 12:34, so I always want to make sure to respect everyone's time. But pretty amazing new stuff. So the summary is Gemini Advanced based on Ultra 1.0. A problem with image generation that Google has removed that, and they said they're going to put that back in. Hopefully they'll make the corrections that they need to make with training their model, and they're going to put that back online in about they said weeks, in a matter of weeks. Gemini 1.5 is not available publicly yet, but I'm sure they're going to do the best they can. You will be able to access that via Google APIs, something that we'll talk about at a later lunch and learn. And then the incredible text to video, maybe that's the most amazing application called Sora from OpenAI. So any questions before we let you back to your lunch hour? And Tushar, thanks for that explanation around Sora and the technology underneath it. Not an easy one to explain to folks.
Yeah, that's so incredible, right? It got me excited. I really wanted to understand what that was, and I wanted to understand from a non-technical standpoint, and that was just so important to me, and finally started making sense. So Tom, there is a question from Ryan. What do you think about the advancement of AI and its impact on hardware? How do you think that might go? I have a view on that. I don't know if you want to go first.
No, I'll let you take that one.
Okay.
I'm a software guy.
That sounds good. So Ryan and others who may be interested in this, my personal view is that this advancement in AI will definitely change the hardware in a big way, and it's going to change the hardware not just in terms of the cloud and all of the cloud architecture and the investments. For example, we met with Tom and we met with the chief architect of Microsoft Federal over dinner last week, and he was talking about how Microsoft is investing $11.6 billion every year, committed for the next 4 years. It can only go up from there. So the amount of investment that is going into hardware at that, the scale is incredible. What they're doing, the type of data centers that they're building, the 4 tiers of data centers, with the final tier, the ultimate level of data center design could be the entire data center submerged, so that there is really no heat dissipation, for example, or that thing completely goes away. I mean, incredible what's going to happen in the whole hardware space, and you see all the momentum with all the chip manufacturing and the crazy stock prices, right? All of that, and some of the meme stocks shaping up in chips and all that. But yes, it's going to change that. Now, coming back to personal compute, I think that's going to change materially as well, and it's going to change in a number of different ways. You can envision future operating systems to be AI optimized, and Apple has put out an announcement about iOS 18, taking the first step in that direction, where it's going to be an AI operating system and that kind of stuff. We have also started seeing some activity from Microsoft and others who are doing optimizing their operating systems to create that AI layer, so that different apps, as they bring in their own AI pieces, all of these operating system level services integrate with those AI services, so that those can be reused, and then they work well with the hardware layer underneath through the operating system, and we'll see what that means in terms of the LPUs and stuff like that. So Tom, that was my take.
Hey, thanks a lot. So in the interest of time, I think we will stop here. And before we go, as usual, for people that maybe this is the first time on viewing one of our AI Lunchbox Series events, we have a Slack community where we want everybody to learn from one another. And next 2 weeks is going to be data analysis, data visualization using AI tools. So our colleague Dhruv Ratra will be delivering those. He's an awesome speaker and very knowledgeable about data analytics and data analytics even in the AI space. So thank you everyone for joining us. Tushar, thank you for helping out here and for your explanations. And everybody have a great day. Cheers.
Thank you, Tom. Thanks, everyone. Thanks for joining. Bye now.